Alright, this is the fourth video in your summer assignment. In your list of assignments, there was a link to another video. I want you to go to that video and watch it first. And then we're going to talk today about instantaneous versus average speed. Before you do that, here is your answers to the last set of homework problems. There's 13 through 35. Go ahead and pause that. And then there's 36 through 50. If you have any questions about any of those, use that website Slader. They have very detailed answers in there. Alright, so like I said, we're going to talk today about instantaneous versus average speed. This is going to be the quickest of all the video lessons, so just bear with me. Alright, so in average and instantaneous speed, hopefully you discovered from the video that average speed is what happens on average throughout a group of time. So average speed during an interval of time is found by dividing the distance covered by elapsed time. The unit of measure is length per unit of time, so kilometers per hour, feet per second, etc. So in this situation we have a problem. It says a rock breaks loose from the top of a tall cliff. What is its average speed during the first 2 seconds of fall? So we want the average speed during the first 2 seconds of fall. So we're going to need the next little bit of information. Experiments have shown that objects will fall y equals 16t squared feet in the first 2 seconds. The average speed of the rock over any time interval will be distance traveled, or the change in y. We call this delta y, the change in y, divided by the length of interval delta t. So what we have to basically figure out is how far this rock has fallen over the 2 seconds. So we need 2 pieces of information. Where did the rock start? And where did the rock end up? So at 0, if we plug 0 in, we know that it has fallen 0 feet. And at 2, 16 times 2 squared, 4 times 16 is 64 feet. So it has fallen 64 feet after 2 seconds. So on average, we know that it has fallen 64 feet in 2 seconds. So on average, it is falling 32 feet per second. Now that's average. What did we just really find there? We really just found the slope. So anytime we're doing the average rate of change, we take f of our larger value, or the y of our larger value, and we subtract the y of our smaller value, and we do the x's. Average rate of change is just slope. Hopefully you remember from Algebra 1 that rate of change means slope. So the average rate of change is the slope of this problem. Notice how I wrote feet per second. That's huge. You have to label all of your word problems, so make sure you do that. Alright, let's look at the second part of this problem. So now it wants us to find it at the instant t is 2. So we know average doesn't mean that it's always falling 32 feet per second. It's not a linear thing. As something is closer to the ground, it's falling faster. So now it wants to know exactly when t equals 2. So think about it still as slope for a second. So what we want to do is we want to think about just a little bit more than 2. So if we find the slope of just a little bit more than 2, and we take away the slope at 2, and then we say, well, this h represents very close to 0. So h is very close to 0, because really, if this is very close to 0, if h is very close to 0, then this number right here that I just underlined is very close to 2. Something very close to 2 minus 2, the value at 2, is going to give us pretty close to the exact value at 2. So if h is very close to 0, we can state that as the limit as h approaches 0. So then we just have to evaluate this limit. So this is f of 2 plus h. That means plug 2 plus h into our equation. Our equation is 16t squared. So I'm going to plug 2 plus h in. And then I'm going to do minus f of 2. So minus, I'm going to plug 2 in. And then I'm going to divide by, well, really I'm dividing by h. And remember, this is the limit as h approaches 0. So now I just have to clean this up. I know that 2 plus h squared is really that FOILed, so it's really 4 plus 4h plus h squared minus, we already know that's 64. We figured that out last problem. And so it's the limit as h approaches 0. So then here we go. We're going to distribute that. So I have 64 plus 64h plus 16h squared minus 64 all over h. That's the limit as h approaches 0 of that. So then I clean this up. The numbers better cancel. And then I can factor that top, let's see, 16h comes out of both of those. So, actually, I don't need to pull the 16 out. It does come out, but I really only need it, the h's to cancel. So I have 64 plus 16h left all over h. So the limit as h approaches 0, we know the h's cross out. We can plug 0 in for h. So really, at the instant t equals 2, the object is falling 64 feet per second. If I plug 0 in, I have 64 plus 16 times 0, which I know is 64. So that's the instantaneous rate of change. If I'm driving in a car and my average speed is 30 miles per hour, that doesn't mean that at other points I drove 60 miles an hour or 20 miles an hour. To get to the 30 miles an hour, I had to drive slower at one point to speed up to that point. So average speed is what on average you did. Instantaneous is what happens at any moment. So like I said, this was a really short lesson. I want you to try page 66, number 1 through 4 right now, and then come back and check your answers. Thank you. Have a good, lovely day.